I'm going to be using the model I'm going to be using to explain our next session is going to be, it's not going to be exactly similar with what we have in our assignments, but this is going to work. If you can understand this, you can use the knowledge you get to work on pretty much any other kind of project. Okay, so here is the two of the um training. So today we are going to be talking about walls creation, and then the properties and some wall model types. Then we are going to talk about beams. We are going to look at how you can create them, then slabs. Then we are going to now look at how we can now apply loadings to our members. Um, and then building set out, then review functions. Okay. So here is our um, model. Okay, this is the plan view, and here we have the 3D view. Okay, so I didn't say this in our last class, but if you want to move the 3D view just the way I am doing that right now, you can just simply hold down on your right click on your mouse and then move it so that you can be able to shift that upon that, just like so. Okay, so here let's go back to our plan view. And in our previous class, we didn't treat some basic modification that you can actually add to grids, or different ways you can now actually modify our grids or axis. That is stretching this axis, or or offsetting them, or moving them, or copying them, and all that. Okay, so let's talk a little bit about that. So when you select an axis, either from the modeling tree or from the structure tree, you are going to get these options on your ribbon. This option that shows you the different things that you can be able to do with this particular axis. So you have this option to offset the axis, move the axis, rotate the axis, and stretch the axis, and different ways you can actually stretch this. Alternatively, you can right click and you can find pretty much all these modification tools that we have here on our ribbon tab over here. So we have the offset, axis, move, rotate, stretch, etc. Okay. So in this when you select it, you're going to get the axis ribbon. It's going to open. The same thing applies to pretty much every other member. If I select this column, for instance, you are going to get the column modification panel. Okay. So let's now see how we can now stretch an axis. That is, if you want to stretch or lengthen an axis. To do that, simply select an axis and then go here. You're going to find this option that says stretch axis. Just click on that stretch axis. So you are going to get this option that says pick a point closer to the end to be stretched of the selected axis. Okay, you can read that out from the bottom line here, just closer to where you have your command line. Okay, so just let's assume you want to lengthen this particular grid or axis. Just select the end where you want to lengthen it, click once, and then drag it out or inside towards the direction that you want. Okay, in this case, let me assume that I want to lengthen it towards this side. Okay, alternatively, I can also do that by imputing a length um of expansion. Okay, or a length that I will want to use to a distance that I will actually use to lengthen it. So to do that, just say stretch axis. I have already selected that. Then click the end you want to stretch, just like so, and then press F2 key on your keyboard or Shift plus F2 key. So when you do that, you're going to get this option that allows you to impute an actual distance. So in this case, I'll choose to impute, let's say 2000 millimeters. When I click that, I just simply say enter, and the axis there is going to be automatically lengthened. Okay, so the same thing applies for pretty much every other axis that we have here. Okay, now to offset axis, so it's very important that we note that uh, when we are offsetting to the left, when you want to offset an axis or any member to the left, you just impute minus, or it's functions just like your graph book. Okay, so when you're moving to the left, you are moving in the negative direction. Moving to the right, you are moving in positive direction. The same thing goes for up and down. Up is positive and down is negative. Okay, so let me try to do that so that you can get what I'm saying. So what I'm going to do first, let's create an axis. So to do that, simply go to your modeling tab and you get this option that says grid. So I'm going to create a new grid by simply clicking on the first point of the section. Hold down your control key to make sure you have your grid aligned to the vertical, and then select the second point of the section. So I will get this grid or something that looks like this. So assuming I want to move this to the left, so assuming I want to move this axis to the left or right, okay, let me assume I want to move it to the right. So what I will simply do, select this axis, right click, and then say move. Then you can move it to the right, just like so. Then if I want to move it by an actual distance, what I can simply do is just select the axis, go to your ribbon here, and select the option that says move. Then press F2 key on my keyboard, F2 key on my keyboard, or Shift plus F2 key. Then you now get this option that allows you to move it by an actual distance. So when you get that option, what you can simply do is just increase the distance with which you want to move that. Okay. So since I'm moving to the right, I'm just going to press the distance 2000 millimeters. Okay. So if I want to move this grid to the left, what I can simply do is just select the axis of grid, say move, and then press F2 key on my keyboard, and then now say minus, since I'm now going to the left side, which is the negative side of your, which is the negative direction. Okay, so now say minus 2000 millimeters, and then say enter. So this is very basic. Anyone could understand this. Okay, so some people. Okay, so people are still in the lobby, so let me admit many people so that they can manage on the meeting. Okay, so okay, so let's now assume I want to move this particular axis either to the left or to the right. Okay, so what I can simply do is that I'm going to select first of all, let me delete these columns. Okay, say okay, then assuming I want to move this particular axis upwards, so what I can simply do, select axis, go to my ribbon, and then you're going to find this option that says move axis. Click on it, and then impute the distance with which you want to move it. Okay, by press F2 key on keyboard, and then say I want to move it by 2000 millimeters, and then say okay. So we are going to get something that looks like this. It's pretty much self-explanatory. Okay, so if I want to offset is simply like duplicating an actual axis, just almost like copying the axis. Okay, so just simply select the axis. For instance, I want to offset this one. Okay, select the axis and then say offset, or alternatively you can right click and then select that option that says offset axis. And when you have done that, press F2 key on your keyboard and then impute offset distance. I want to offset this particular axis downwards, so I can now say minus and then the offset distance, which I would want to be 2000 millimeters, and then say enter. So basically this is just a basic modification skill or way to modify your axis. Okay, so it's going to be what you have learned, what I've just shown you is going to be very much useful for your basic modeling. Okay, but during the advanced classes, we are going to be treating more advanced ways of modeling and how to deal with your axis. Remember that your axis is the first step of modeling. When you have gotten your axis right, your modeling, there's every chance that you are going to have a very perfect modeling. Okay, so this is actually what we are supposed to cover in the previous lesson. So without wasting much of our time, let us now go straight into what we have for today. So I'm going to delete this axis now. Say delete so that we have this one just like so. Okay. So first of all, I would before we go into what we have, I would like to show us something that is going to be very, very useful and interesting as well. Okay. So if you want to change the section property of your column, for instance, we have here this column. It's a square column which measures 25 by 25. Okay. So if you want to change the section of this column from rectangular or square to circle or any other shape, okay, what you can simply do is just select the column, then right click and then say properties. You're going to find the properties option. Alternatively, you can simply go to the ribbon here. When you have selected the column, go to the ribbon, you're going to see this option that says properties. Click on that. Properties. Okay. So we have it here. This is our properties dialog. You're going to get this properties dialog over here. Now you're going to find this little rectangle that says section manager. Click on that once. When you have clicked on that, you're going to get the section manager dialog. Okay, so this is where you get the different sections that are available in Protastructure. Okay, so we have the circular section, we have the TI section, follow section, angle section, and the cross section. Okay, so we also have still members. This is for complete members. We have still members and composite structures as well. Okay. So in this case, I'm going to select the circular section if I want to change that to the circular. We have the option to also change the diameter of that. Let's leave this as default. We will still have the option to change the diameter in the properties dialog. Okay. So when I've done that, simply say OK. Then we can now modify the diameter of that circular column. Okay, so let's assume 500 to be the diameter, and then when I say update, make sure you click update. When you have done that, you are going to see automatically this column has now changed. The section of this column has now changed to be circular. Okay, when I go to the 3D view, I'm going to get the center. Okay, this is our circular column, and this is what it looks like. Okay, so let's do the same thing for this column as well. Okay, let's also do the same for this column. Select the column, right click, go to the properties first, then go to the section manager, select the column, the circular column section, say OK, and then now change the diameter to whatever you want. So in this case, I want 500 millimeters. Update and then say close. So we have now successfully changed the section of this particular column to be a circular section, and we also have some rectangular sections as well. You can change the sizes if you want, but we are going to leave it like this for the time being. Okay, so without wasting much of our time, let us simply go straight to what we have. So today we are going to be talking about modeling. We're going to be covering everything you need to know with regards to modeling. Okay, so first of all, we are going to learn how to model our wall. Then we are now going to learn how to model beams. Okay, so now to model your wall, simply go to the ROC modeling tab over here. The modeling tab, and then go to the ROC member section. Then select the option that says wall. You are going to get this option, this property dialog. So we are going to get this properties dialog. Okay, so here we have the option to change the breadth of our wall, and the breadth is simply the width of your wall. So in this case, is by default 250. You can change it to whatever you want. And here we have the extension I and J. So the extension I and J is used to it's a tool used by Protastructure to lengthen the wall by a small distance. Okay, so if I want to create my wall, what I simply need to do is to select the first point of insertion and then a second point of insertion. Okay, so remember that whenever you are creating any of the members, your points of insertion has to be at axis intersections. So you cannot create any member at any place that is not an axis intersection. Okay, or else you're going to get a warning error. Okay, so I'll create a wall. Let's create a horizontal wall. First of all, over this axis intersection, you're going to see this option that says axis intersection. Click on that, then click on your second point of placement or insertion. When you have done that, you are going to get something that looks like this. So we have now successfully created a horizontal wall. So we have here one wall one. This is simply the level, and 3250 by 250. This is simply the dimension or the length and then the width. So this 250 is actually the breadth or the width, which we have here B, which is 250. So here we have E. E is just the eccentricity. So eccentricity is used to adjust the positioning of a of a member. So we can use eccentricity in beams. We can use that in columns or walls. Okay. So eccentricity is actually used in advanced structural design or engineering. Okay. So here we have the extension I, and then we have your extension J. So extension I and J properties are actually used to lengthen the length of the wall by some little distances. Okay. So here the extension I, or the I end of any horizontal member is always the left end, and the right end of any horizontal member is your J end. So Protastructure uses that kind of that function to know which end of a horizontal or vertical member that is going to be specified. So when you have drawn a vertical wall, just like this, so we are going to draw another one. We are going to get something that looks like this. Okay. So the bottom end of a vertical wall or a vertical member is always your I end, and the top end of a vertical member is your J end. And for the horizontal member, the left end of your horizontal member is always your I end, and the right end of your horizontal member is the J end. For the vertical member, is the same thing. Bottom end, I end, and top end, J end. So here you have the extension I and J. Remember I said the extension is used to lengthen the wall by a small distance. Okay. So if I want to lengthen this wall by a small, let's select the wall and take the properties by double clicking or right clicking and then say properties. So we are going to find out that the extension I of this particular wall, which is the left end, is 125. So the distance between the base of this wall and actual insertion point is 125 millimeter. I can change that to 150 millimeter, or let's say 200 millimeter. And then when I now say update, you are going to notice that this wall is going to the length is going to increase. So simply say update. Okay, as you can see now, the length, that is the I end or extension I just increased. The same thing here. Here is still 125 because we left it at that. So we can change that. Let's assume 300. Okay, then say update. So you're going to notice it's just updated. It just changed. Okay. So I will now advise you that whenever you are modeling, always keep your extension I and J minimal, because they are not actually designed to carry any member. So don't have huge length for your extension I and J. Okay, just take it um from a minimum of 0 to a maximum of half of the width of the wall. For instance, if I have the wall of 300 millimeters, I will now, it is more reasonable to have my extension I and J to be 150 millimeters at max. Okay, so moving on, that is simply how to create your walls. Then moving on, we have this option that says top I and J. This top I and J are simply the axis placement the axis intersection, which was used to place this particular wall. When you select one, you're going to find all these properties. So go to geo. This place that is within geo, it simply means geometry. So we have the plane top and bottom options. So these plane options are actually used to adjust the elevation of the wall. And here we also have delta z, high top, delta z, um, high top and bottom, j top and bottom. So this delta z options is used to adjust the 3D height and the offset of the wall. So by default, it follows the height of the story, which is 3 meters, because we have not set it. By default, it's 3 meters, okay? So by default, it follows the height of the story. So I recommend that you leave it and do not alter the changes for now, okay? You can still alter the changes later if it is required. Then here we have this option that says support types, leave that as default. And then here we have this 4 different options. We have the default wall, mid-pier wall, finite element shell model, basement wall, and all that. So the mid-pier wall is simply your first concrete wall that is usually used for lift shaft or the core area of your building. Okay, that is where you usually have your elevators, because the walls around that place is actually made of your reinforced concrete. And here we have finite element shear wall, and then we have your basement wall. So the basement wall is the option that you select if you are modeling a retaining wall. That is when the wall is now going to be supporting lateral earth pressures, okay, or lateral loads from earth, okay. So here we are now going to delete these walls. And now let's now model our walls the way we would want that to be. So to delete this wall, simply select that, then press delete to enter. Now go to the modeling tab, click on walls. So I would want the width of my wall to be 300 millimeters, and then the extension I and J to be 150 millimeters as well. And then the geometry. Okay, so we are going to leave it as mid-pier wall. When we set this by default, it follows the first option. This option that says mid-pier wall. Okay. So now let us now place our walls where we actually want to place them. So let's assume I want these walls to be here. So let's place the first one, place the second one. So as you can see how I'm actually placing these walls at axis intersection. If I attempt to place these walls in regions that is not that doesn't have axis intersection, I'm going to get this one that says cannot find a common axis but element insertion. Pick the insertion points again. Okay, so you're going to get this warning when you try to place at regions that is not an axis points or regions. Okay, so let's continue placing our walls. So you're going to get something that looks like this. And this is exactly what I want to get. Okay. So this is not a real life project. This modeling is actually created for the sake of teaching this software. Okay. Nice. So when you're done with that, simply say cancel or then or close. So let's go to 3D view and see what we have now successfully created. So this is our model, and this is what it now actually looks like. So we have now successfully treated the first thing on our agenda today, which is walls creation and their properties and the wall model type. Next thing we are going to be looking at the beams creation and properties, and then different ways you can create beams. So simply go to your plan view. When you have done that, you are going to get something that looks like this, obviously. Then when you want to create your beam, it's very, very similar with wall creation. Click on those beams, select normal beam, and then we are going to get this option that says B. B is simply the width of your beam. So I'm going to reduce it to 225, because since we have 225 um 225 by 225 square columns, it's only reasonable to have a beam with the width equal to the width of the column or less than that. Okay, so I'm going to leave the height, that is the depth of the beam, as 500 for now. and the B to be 2 to 5. Eccentricity 0. I'm going to leave that as 0. So now I can now start placing my beam. Now to place your beam, simply select a first point of insertion and then a second point of insertion. Okay. So your first point of insertion can be a column insertion point or an axis insertion point. So if you hover around that region, if it has any column, you're going to get this option that says column insertion point. So I prefer using the column insertion point, but it's pretty much the same thing with the axis insertion point. Okay. So now select a second point of insertion. When you have done that, you are going to get something that looks like this. Okay. So this is actually our first beam. We have now successfully created that. It says here 1 beam 1 225 by 500. Now let's continue creating the rest of our beam. So we can continue doing that one after the other, or we can just simply go to the last beam, to the last column where we have here, and then click there. So we are going to get multiple beams. You're not going to get one singular beam because anywhere you have columns here, the beam is going to be broken up. So you can observe that we have here 6 different beams. Okay, you can also observe in your properties dialog, just on the story 1 folder, open up the beams folder, you're going to see 6 different beams. You go to the 3D view, you are going to get something that looks like this. So now let's now continue creating our beam and create the rest of the beams for our model. So instead of going to the beam tool again and then start setting up the properties, you can simply take the properties of this one by selecting that and then say properties or double clicking on that. So and then let's continue creating. Alternatively, instead of creating the beams one after the other, you can now draw a window selection and then beams will be automatically added to regions that have axis intersection or column intersection points. Okay, so let's draw a windows like this. We are going to get this. And let's continue. So please bear in mind that your beams cannot be created where we already have walls or where we already have existing beams, because your beams are actually your walls are actually self-supporting. Okay, so beams cannot be created where we have existing walls or existing beams when we are using that selection um that cross selection method to insert our beam. Okay, so let's continue. We have now inserted one here. Let's now insert one here. Let's now insert one here. Okay, so that's fine. So let's insert 2 more columns here. Let's take the properties of these columns. Let's insert that here. Now let's take the properties of this beam so that we can actually extend this to this place. Okay. Let's delete that. So I don't know if anyone can still hear me. So please, if you are hearing me, you can unmute yourself and raise your hand so that I can know
We
who
can
is
hear you.
hearing me. Okay, thank you.
We can hear you, boss.
So okay, let's continue. So now we have now successfully created our beams. If we go to the 3D view, we are going to get something that looks like this. Okay, so now let's go to our plan view. Let's now learn how to create curved beams. Okay, so when you want to create curved beams, what you can simply do is using the curve method of insertion. Okay, simply select a beam to take this particular beam's properties. Select it and then say properties. Now make sure you click on this option that says curved beam insertion just at the properties dialog. When you click on that, you now select the first point of insertion and then the second point is for insertion. So you are now going to get this option that allows you to snap it wherever you want. Okay. So you are going to input an actual radius of conversion. So for that, I'm going to press Shift plus F2 on my keyboard, and then in this case, I will just say minus um 600. I will assume minus 600, and then say enter. So because it's going the other way, that is why it is minus. Okay. So this is what the curve beam is going to look like. So let's add something similar like to that here in case if we didn't get it the first time. So simply select your first point of insertion. I want it to be at this column insertion point. I'll add this intersection point. Then select the second point. And when you get this, press Shift plus F2 on keyboard. So in this case, I'll say 600 and then say enter. So when we have now done that, we are going to get something that looks like this. So here we have created two curve beams. You can go to our 3D view to see what it looks like. Okay, you can also zoom in to see what that looks like. So we have now successfully created our curve beams, and we have now also created our straight beams as well. Okay, so the next thing we are supposed to be doing is to start learning how to create our slabs. Okay, creating slab is the easiest of modeling. Okay, so to do that, simply go to the ROC member section, click on slabs, and then you're going to get this option that says load cases must be defined before load assignment. Just say yes. Okay, when we have done that, we are going to get this load combination editor dialog. Okay, simply click on generate loading generator. So you are going to get these various options for your loading to generate your loadings. Okay, so this is simply the loading combination. This is simply the loading combination that you're going to use to design your building or structure. Okay, in the advanced class, we're going to spend the time to explain all these things, why we use them, and how we would actually use them. So, but basically, it's just a technique used by different design codes to estimate the performance of the building under the worst loading condition. It combines notional loadings, dead loads, live loads, wind loads, and then check the maximum or the worst condition that can lead to failure, and then check the performance of the structure or building under those loadings. Okay, in order to discourage failure or collapse. Okay, that's by the way. In our advanced class, we are going to explain about that. But when you have clicked on that, don't change anything for now. Simply say okay. And then when you have done that, then say okay. So right now we are now going to get our slab properties dialog. So here we have the L1. So L1 is the label. Label here we have 1S1, which is simply the label of the slab that I would want to place. Here we have the slab type. So the slab type from 1 to 12. This slab type from 1 to 12 actually relates specifically to a table in the BS code of practice. That is table 3.14, yeah, of the British Standards Code of Practice. Okay, so these are different types of slab with respect to the continuous edges, discontinuous edges, and others, long span and short span, and aspect ratio. Okay, so I would advise you to leave the slab type as slab type 1. So the software or the program has the function that automatically resets each slab to the or correct each slab type to the correct type. Okay, so here we have the H. H simply is the depth of the slab. I want it to be 150. So in the BS code of practice, there is a minimum depth of slab that is needed to be provided for story buildings. Can anyone hear me? Okay. Although we are using the Euro code, but still that the BS code, the Euro code is actually um um in a way created from the BS code, although the BS code um became obsolete, okay? But still, this some certain rules actually are is very similar that are in the Euro code and are also in the BS code, okay? So one of those rules requires that there is to be a minimum depth of slab that is going to be provided for any slab, okay? But in my case, I would want to use 150 millimeter, which is pretty much the most common depth of slab that we use in our country. Okay, here we have concrete cover to be 25.0 millimeters. We are going to leave that as default. Now, to start placing your slab, what you can simply start doing is just to start clicking on each panel where you want these slabs to belong to. So, for instance, I'm going to click on this place, click here one. So when you have clicked there, you're going to get the slab automatically placed. Now continue clicking at every region where you want your slab to be placed at. Okay, so you can take your time slowly and make sure you insert your slab at every place that you want. So there's no need for me to insert my slab at this um, shafts or lift area. Okay, so I'm just only going to be inserting my slab at only this panel, only at this panel. Okay. All right. So let's close this up and let's go to 3D view. So you can see what we have now successfully created. So this is what we have now created. So this is our model. We have now successfully modeled the beams, the slab, and then the and our columns. Okay. So go to the slab again. Let us now look at the loadings. So here we have the option to enter the set weight of the slab is automatically calculated, and here we have the um, dead load weight on the slab, or the dead load on the slab. Okay, so I will choose the room loading, which will give me 2.38 kilonewton per meter square. Then I'll come back to this place where we have the post load, which is the live load. Right click and you get the option to add the use of the building, or the um dead load corresponding to the use of the building. So I will assume this is a residential building. So I'll just say the first one, and we are going to get all that. You can see update to reset that. Okay, but we didn't set that before we started placing our slab. Instead of deleting our slabs and starting afresh, what we can simply do is that we can now simply right click, come to an empty space, right click, and then you are going to get this option that says member tables. Look for this lab table, click on it once. You are going to get this lab table dialog. Okay, this lab table. So we have here your additional dead loads, which is simply the dead load or weight of the building, okay, of the slab, self weight of the slab. Okay, so um click on this option. It allows you to choose. So I will use room, then say okay. It's going to be automatically applied to all of them. So there, here we have the imposed load. Just click at the top, then get this option that allows you to edit it. So I use the general domestic use and then say okay. So we are not going to add roof loads, no loads, REnT loads for now. We are going to leave the concrete cover as 25 millimeters, and when you're done that, you'll simply say close. It has now been successfully added. Okay, so we are going to we are also going to notice that each and every member that we have created actually exists here on our structure tree by the left. Okay, so we have now created columns. If you click on this drop down arrow, you're going to get this column insertion option, And if we click on this one, we are going to get all the shear walls. You can select them from here. Let's choose to leave it for now. Okay. So, but before you go into our next thing, so I want to know if you all are actually seeing my screen very well. If you are still following, so please, if you are still following, just you can unmute yourself and say something so that I can know if you are all still here.
Yes, but
Yes,
I
sir.
don't know from my end, your voice and your operations are not doing anything.
Okay. Is there anybody getting the same issue or error? Okay. So nobody, I assume nobody. So we are going to move on. So moving on, the next thing on our agenda is now loadings. We are going to be treating wall loads actually. So we are going to know how to apply wall loadings on our team. So I want to assume that you have watched our pre-recorded videos, okay? So now to add wall loadings on your beam, what you simply let's go to the plan view. Then what you simply need to do is to first of all create a particular wall loading. To do that, go to your loading tab over here, and you're going to find this option that says partition wall loads. Click on it once. So now you are going to notice that we already have some different walls, sizes and loadings and all that. Okay, and there are actual total loads. These are basically response from users or feedback from users across the world. But we are going to be creating our own with our actual unit weight and actual required values. So to do that, simply come here and say add new load. You're going to see this option. Click on it once. Then rename that to whatever you want. So in this case, let's say 2 to 5 walls. And let's leave it like that. Okay. So now we are now going to start adding these different loadings. So let's add a new layer. But before we okay, when we have now added the new layer, we are going to select the material. So what we actually need here is a block with the unit weight of about 24 kilonewton per meter cube. But we are not seeing that here. What we are going to do is that we are going to create a new material. So go to this option that says edit material. Now add one. So let's rename this one. This one we have now added. Let's just say blocks. And when we have done that, next thing we can now do is add the unit weight. So I want to assume the unit weight to be 24 kilonewton per meter cube. Then let us also add another loading, which is our finishes, plaster and finishes. Okay, plaster and finishes. Let's assume the unit weight of that to be 50 kilonewton. No, not 50. 20 or 18. So in this case, I'll just use 20. When I've done that, I now simply say OK. Now come here and then select the materials that you have now created and add it to these 2 to 5 walls. Open that and then say blocks. Then we are going to add first the thickness of that in millimeters. So I want that to be 2 to 5. And then the loading value here is going to be automatically calculated. Let me expand this so that you can actually see that. Okay. So now let's now add another loading for our plaster and finishes. Okay, let's click on this, and then the unit weight is 20, and the thickness 25 on each side of the wall. So it's going to be 50 in total, and we are going to get the loading value. And here we have the total loading, which is 6.4 kilonewton per meter square. Then say okay. So we have now what we have done is we have created a wall load, but we have not actually applied it to our beams. So we are now going to be applying these wall loads to our beams. Now to do that, what I can simply do, can do that from the plan view or from 3D view. So let's do it from 3D view this time around. So select the beam. We're going to get all these options here. can also get this option by right clicking, but in this case, let's just say edit loads. Go to this place, you are going to get this option. Click on edit loads. So you are going to get the load editor um dialog for that particular beam. So we have different loads that you can actually add to this particular beams. I'm going to be adding the wall load. That's the one we want to add. So we have the uniform load, points load, trapezoidal load, partial wall loads, and all that. So we have many loadings here. You have the wall load library. It's by default set to user defined. So the unit weight of the wall that we are going to be adding, we can now be changing it from here. But since we have already created a particular wall, what you can simply do is to click on this drop down arrow and then select that wall, 2 to 5 walls. Select this. And here we are now going to have the unit weight of the wall here automatically. When you have done that, simply click on this beam here. Click on it once. Then find that just like any 3D view. And then when you have done that, just say okay. So when you have done that, this is what we have now successfully created. Okay, so we have now successfully created a wall loading on this particular beam. So what I can do now is to now select this wall, select this particular beam, copy this. I can repeat the same thing for every beam in the model. Okay, so but a very fast way to do that is to just select one particular beam and then copy the loads. Come here and say copy loads, or right click and then get this option that says copy loads. Then I want to copy the wall loads. Copy that and then say okay. Now select all the beams in the model and then now paste this particular wall load to them. So to do that, simply come to your structure tree, go to the story one, open up the beams folder, select the first one, hold down your shift key, then select the last one. Now automatically select all your beams in the model. You can see they are all red in color, which means they have now been selected. Right click and then say paste loads. So yes, that's happening. Okay, so we have now successfully pasted all the loads that we want to our model, to our beams. Okay, all the wall loads. Okay, so please bear in mind you have the option to delete the wall loads at places where the beams that are not carrying wall loads. So it all depends on your architectural design that you are going to follow. Okay, so this is just for training purposes. Okay, so we are almost done with our model. So let's check the next one on our agenda. We are now going to be going to the building setup and then the review function. Okay. So in building setup, what we are going to do now is we are now going to now create multiple floors. Okay. So you are going to notice here we have story 0 and then story 1. So by default, this is what you get, story 1 and then story 0. Okay. So if you want to add multiple stories, even up to 100 stories, we can do that. We are now going to add multiple stories. So I'm going to assume we are designing for a 3-story building. Okay. So I'm going to add multiple stories, then copy all these members to every other stories. So go to your building setup tab and then go to the operational stories option just by the extreme right. Click on that once and you get this option that says insert stories. Okay, click on it. So what you're simply going to do is to create stories. So please pay attention. Protastructure recognizes the roof level as an actual story. So that simply means that if you are creating a 2-story building, the roof level, that is the final level, Protastructure recognizes that as a story. So if you are designing for a 2-story building, you need to impute the story number here as 3. That is the 2-story plus the roof level, which is the third one, which makes it 3. If you are designing for 4, then that means you have to impute here 5. If you are designing for 5, you have to impute 6, and so on. So I want to assume that I am designing for a 3-story building. So with that, what I can simply do is to come to this story number and then say 4, which is the 3 stories plus the roof level, and then say okay. So here we have all these options. Leave every other thing as default. Say okay. So we are going to get this option that tells you that whatever you set up now, you are not going to have the option to undo that simply by pressing Ctrl Z. Okay, when you have done that, you're going to get something that looks like this. So what we have only done is to create these stories. We have not modeled anything there. So what we are going to do is that we are going to model all these members in all those stories. There's a faster way to do that. Okay, go to your structure tree. You are going to notice 3 additional stories here. We have one here, then we now have 3 additional stories, which is story 2, story 3, and story 4. You are going to notice this circle around story 1 is actually shaded, and the circles around every other stories is not shaded. That is because there are no members actually created in those stories. So we only have members created in story 1. That is why this circle is shaded. Okay. So now let us now start duplicating or copying our members, that is generating our members to the rest of the stories. Go to your building setup tab and go to the story operations and say generate stories. Now make sure, okay, before you do that, make sure that your story 1 is active. That is the story that you're going to generate members. Make sure that story that's active to our first story, which stories, and then say generate stories. So now our source story is story 1. Our target story is going to be story 2, 3, and 4. When we have clicked on that, we are going to now have the option to select the member type to be generated. I'm pretty much going to be checking everything here. Okay, let's say okay. So you are going to notice in our background, the stories are being generated. Okay, it says here, process completed. Just say okay. Okay. So you may be getting some errors depending on the version you are using. When it's done, you can now simply close that. Okay, let's wait for it to move. Okay, don't know what's going on. Okay, the software is misbehaving, so this dialog is not going to be. Okay, so it's gone. So here, this is what we have now successfully created. We have now duplicated or generated our model to the remaining stories and the rest of the stories, and this is what we have. So here we have our columns, we have our shear walls, and then we have um, our beams as well, and then our slabs. Okay, so this is what we have now successfully achieved. And the next thing on in our agenda is the review functions. Okay, so when we have now finished creating our columns, let me explain the meaning of all these labels that you're seeing here, because you are going to be seeing things like 1:1, 1:2, and 1:4, and all that. Okay, so here whenever you see 1:1, this simply means one um Wherever I see one C1, it simply means story 1, column 1. So this is column 1, this is column 2, this is column 3, this is column 5, this is column 7, this is column 9, and it goes on and on. Okay. So the one here, which is the prefix before the C1, is simply the story. So all these columns are in this particular first story. That is why you get 1 column 1. And then when you go to story 2, go to your structure 3 and right click that, make your story 2 active. And you're now going to notice that all the columns here are 2 column 1, 2 column 2, and the rest. So this is story 2 column 1, story 2 column 2, and all that. So now the same thing goes for your beams. We have 2B37, which simply means 2B37, which simply means story 2B37. Then 225 and 500 is simply the dimension B and D. Okay. So the same thing goes for your walls, and the same thing goes for your slab 2S11. This is 2 slab 11, and when you go to the story 3, you are going to get the same thing. So instead of 2, you are now going to see 3C1, which is 3 column 1, and it goes on and on just like so. Okay. So now you are going to notice something that is very, very disturbing, and that is that is the fact that our columns are not well arranged or labeled. We have one C1 here, one C2, and one C5. It jumps to one C7, and here we are now getting one C16 and one C18. So usually you would want that to be labeled sequentially so that you are going to be able to track exactly what you are doing. So there is a function that allows us to do that here in Protastructure, even after you have done finished modeling. So what you can also do is that the long way around that, just select a column. Let's assume you want to reset the label of this column. Select the column, right click, or go here and say properties. You have the option to rename the label of the column from here, and that is going to be a very, very tedious process. Doing that for, you can imagine, all the models in your building. Okay. So what you can simply do is just simply go um to the reviews tab over here. All right. Okay. I just noticed many of us are asking for the course code. Okay. So the course code is going to be Prota 222. Yes. I'm going to make the course code not to be predictable. Okay. Just say Prota 222. That is simply our course code. Okay. Look at this over here. Prota 222 is our course code. Okay. So now let's now go back to the review function. So simply go to the um reviews tab, just near your loading tab. You're going to get this option that says relabel members. Click on that once, and then you're going to select all the members that you want to be labeled. I want to relabel my axis, columns, shear walls, beams, frame members, although we don't have that. So yeah, just look at this and you're going to, you can easily understand how what this option does. So this just tells you how you want to be renaming them. Is this from left top to right top to left bottom to right top, and so on. Same thing goes for horizontal members, and same thing goes for axis. So I'm going to leave it as default. It's actually set to the way I would want that by default. So simply click on OK when you are done. So this we have this option here that says retain compatible members between stories. Member number start value 1 and all that. Okay. So this return these options um this if this option is checked, the columns at the same intersection, or the members at the same intersection points is going to be labeled with the same thing. That is suffix after the letter. Okay, so they are going to be labeled as the same thing. So I can do that if I want. So let's just do it and then say okay. So when we have now done that, you are going to notice now that our um, members have now been um, well labeled. Okay, so we have 1C1, 1C2, 1C3, 1C4, 5, 6, 7. It's now labeled the way we would want that. Okay, so this is exactly what we are supposed to be covering today in our class. So we have now successfully covered everything that we need to do. Now for your assignment, do a complete modeling of your previous design block. So that's model that we created the building, we created the columns and axes. So what I can simply do, let me just go back to that model to show you what you're going to do for assignment. So I'll close this one right now. Just click on this place that says close project. Okay, now this is that project that we have been working on. Okay, so this is what we've created and this is what it looks like. Okay, your assignment, this is what it now looks like. Okay, what you're now going to do in your assignment is simply complete the modeling. Everything that you have now created, simply create beams, slabs, just beams and slabs. Okay, and you may still have the option to um create your walls. Okay, so now let us see. Go to your modeling tab. And then first of all, let us turn on our DXF drawing. Okay, to do that, you can simply go to external reference drawing. We are still going to have this here. Activate that and then say okay. So select the beam. Go to the beam tool here, modeling panel. Go to the modeling panel and then select the beams tool. Select the beams tool and then start adding your beams in the regions where we have it, just the way this thing is now modeled out. Okay, so you add from here to this place that colonization point. Do the same thing for this place and make sure you model all your beams. I'm not going to be doing that because of want of our time, because I actually want to take some questions before it's 10 p.m. So add all the beams, make sure it is 225. Here I have 250 millimeters. Just double click on that, take the properties and change that and update that. Make sure the depth of your beam is going to be 450 because that is more reasonable. So when you have now actually done that, go to your modeling tab. You are now going to be getting this option that allows you to add slabs at beam boundaries. So add slabs to your building. Go to your building setup tab, operational stories, and then insert stories. So I want you to model for a two-story building. Model for a two-story building, which simply means you have to add when you're inserting your stories, the number of stories you're going to create is going to be 3, which because you're modeling for a two-story. Okay, so model for a two-story building, and that should be that. So now add your slabs here. Okay, let me show you something that you're going to do. So for this region, okay, okay, so just watch carefully. So you are simply going to be modeling your building just the way I'm doing for this one. So please bear in mind that you still need to change the 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 width of your beams and also the depth of your beams. Okay, so now um let us now add a slab. I want to show you how to create slab opening. Okay, so click on the slab tool Okay, it says load cases must be defined. Loading generator. Say okay. Say okay. And then when you come here, set your slab depth, the dead loads and live loads that you would want, the general and all that concrete cover, and then come to this place, place your slab. Now exit. So this building was actually created um requiring this particular region from here to this place to be a slab opening. Okay. So this model is very similar to what to a project building that I've worked on. Okay. So here we have this slab opening here. So this place is going to be opening. So it's going to be opened. Okay. So to add a slab opening, simply go to your modeling tab, and you're going to get this option, this little option that says slab opens or drop. Click on it once, and then simply come to this place and draw your slab opening, just in a rectangular way. So when you have done that, you're going to get this opening. Okay, so you are going to get this X, which simply tells you that there is a slab opening here, there is a void here. So when you go to the 3D view, you're going to get something that looks like this. But before then, I expect you to model all the beams here, add slabs every other places in every other panels here. Okay, so that is that. We have now finally come to the end of this training. Um, okay, so now we are now going to be taking questions. Okay, so if you have any question, you can now unmute yourself to ask the question. Okay, if you have any question, anything at all, I actually expect you guys to have questions. Okay, because I noticed I was becoming too fast, and most of you here are still beginners using the software. Okay, does anyone have any question?
Uh, Sorry, good evening.
Good evening.
Please, I don't know if you can go through the assignment question again. My network was coming on and off, and you weren't clear. We had to model beams, slabs, and a story. Or what did you say? I didn't really get.
Okay, for your assignments, you are going to be modeling a two-story building. Okay. Can you hear me?
Yes, I can.
Okay. So for your assignments, what you are going to do um is to create model beams, model columns. You have already modeled columns and axes. Just use the same to model beams, and then your columns, and then model slabs, and then add a slab opening in that region where I showed you, right? Add a slab building. Then it is going to be for a two-story building. You get. So what you are modeling for is a two-story building. Okay, so I'm going to share my screen so that I show you what I mean. Okay. Okay. This project I just opened it up. This is a project that we actually used before. That REnT is actually using to for some of their trainings. Okay. So this is actually a two-story building. Okay. So yeah, you can see here is just the ground floor area. Here is the first floor, and here is the second floor. So please bear in mind that your roof or your top level doesn't have slab. So you're not going to be adding any slab on the roof level. So you're going to remove all the slab. I'm supposed to remove all that. And this is a design that you have actually finished. So this is simply a two-story building. What you're simply going to be doing is to model a two-story building. Model your columns using that particular DXL drawing, okay, that we have provided. Okay, so let me go to story one, and let me turn some things off so that you can actually see this very clearly. Okay, display tab, visual interrogation, visual interrogation, and we have display. Let's turn this off and then say okay, and then let us know. Let me open that external reference drawing. This is the external reference drawing that we use. Let me go to 3D. Okay, so you can notice it there. So I actually use this external reference drawing to model this. Okay, so we have now successfully completed the analysis and design of this particular building. This is actually the model we used in your pre-recorded videos. Okay, so this is what I expected you to have. So this is the design status. You can see showing that the building has successfully passed design. The green here simply means okay, and if there's anyone showing red, it simply means that that member has now actually failed. Okay, so in your assignment, just model columns, beams, slabs, and then make it a two-story building. Make sure you go to the review functions and then make sure that um your labelings are well aligned in the same way that I have shown you to do that. Okay, so that is that. I don't know if I answered your question.
Yes, you did. Thank you.
Okay, so that is fine. So does anyone have any other question? Okay, Engineer Henry, I don't know if you are here. So I don't know, would you like to say anything? Okay, Engineer Henry is not here. Okay. Having said that, I think we have now come to the end of this training. Okay. So in our next training, what you are going to be looking at is analysis and design. We are going to look at how to design foundation. Basically part foundation. Okay, so that's what we are going to be treating. So I want to encourage you. I know most of you are coming new to this space. I mean, using this software. Just do whatever you can do to make sure you are following up with whatever you are doing. It is going to help you in the long run. Okay, so many people don't know how to. Many civil engineers may not know how to do structural designs and all that, but you are getting this opportunity almost for free. Okay, just make sure you engage yourself with everything we are doing and make sure that you're staying here in this meeting is not to waste your time and waste our own time. Okay, so that is that. I also noticed only one person have seen the assignment in the first class. So I don't know what is holding every other person. I don't know whether you didn't understand or anything. So please do your modeling, post the previous assignment and also put the second assignment. Watch the pre-recorded video for the third class and then